All right. We're going to get started today with practice exercise number 25. So if you would, go and take your practice exercise booklets out, turn to page 8, and we'll do that last exercise on that page, exercise 25. 4 problems. For you to work, you may use a calculator. If you're watching, please pause the video while you work and resume when you're finished. All right, let's go and take a look at our answers. And Michael, you were first. It says George Mikan, who played for the Lakers from 1947 to 1956, way back in the day, scored 11,764 points. If this was an average of 22.6 points per game, find the number of games he played for the Lakers to the nearest whole game. Michael?
521.
521 games is approximately the games played for the Lakers. Second problem, while playing for the Chicago Bulls from the 1986 to 1987 season, Michael Jordan scored an average of 37.1 points per game, just in that one season. How many more points per game did he average than George Mikan? What did you have for that, Michael?
I rounded it to 15.
It didn't ask for you to round to the nearest points per game. I think it would round to 15. Yeah, it would round to 15. What is it though, Abby?
14.5.
14.5 points per game. Stay with Michael. George Mikan was 208 centimeters tall. If a centimeter equals 0.39 inches, find his height in feet and inches, remembering that a foot is 12 inches. Find the inches this time to the nearest whole inch. So how tall was George Mikan? Michael?
1 inches.
Sorry?
1 inches.
Yes, but it wanted it in feet and inches. Find his height in feet and inches. What did you have for this, Abby?
I had 6'9" inches.
6'9" inches. 6 feet 9 inches tall was our answer. I'm going to go to Abby for this then. Michael Jordan is 6'6" inches tall. If an inch is 2.54 centimeters, find his height in centimeters, rounding to the nearest whole centimeter. 198 centimeters is correct. All right, yes, sir.
I read the feet in inches, so I did 1 in inches, and then I did 1 in feet.
Oh, you did write feet in inches. Oh, so you just read me the wrong answer.
Kind of.
Oh, I thought you were just trying to be nice and give Abby the chance to get the candy. I don't know, that's what it was. All right, everyone else get them all correct. Michael sort of got them all correct. Brandon, you got them all right. Good, Adam. Anyone just missed one of them? You got 3 out of 4? All right. Any questions on any of those of how to work them out? Any questions on how to work any of those out? Yes, sir.
I don't know what I did, but I got 6'7"
For George Mikan? So what you do on your calculator is you take the 208 centimeters and multiply by 0.39, and that'll give you approximately 81 inches. Then you can divide that by 12, but you're not going to do it as in a decimal value. You're going to do 81 divided by 12. Well, 12 goes in 6 times. Subtract 72 away, but the 9 becomes 9 inches. So 6 feet 9 inches. All right, good. Any other questions? Yeah, Lana, is that a hand?
Yeah, the second one.
The second one, how many more points per game did he average? Well, he averaged 37.1, and just during that one season, not over his whole career. George Mikan, over his entire career, averaged 22.6. How many more? You just subtract.
Oh.
So that's where we
I
get the
was thinking that you had to
14.5.
divide something and then subtract.
No, just subtracting the 2 average points per game. Josh, question?
The first one and the last.
Okay, the first one, if he averages 22.6 points per game and he scores, okay, so here's kind of the way to think of it. When you average something, you take the total, right? You add up to get a total, and you take the total, divide by the number, and it gives you the average, right? Well, we know the total number of points is 11,764. We know that the average is 22.6. What we don't know is the number of games he played. Well, let's just say 8 divided by 2 equals 4, right? But let's suppose I didn't know the 2. 8 divided by what equals 4? 2. The way we could get it is actually divide the 8 by the 4. So if you divide the total points by the average points per game, it'll actually give you the number of games, and that's what we had to do on the first one. On the last one, 6 feet 6 inches. Remember, a foot's 12 inches, so 6 feet is how many inches?
72.
Plus 6 more gives us Michael Jordan's height as 78 inches tall, right? But if 1 inch is 2.54 centimeters, we multiply by 2.54, and that's where we get approximately 198 centimeters. All right. right, go and pass those in if you would, please. And you can keep your desk cleared for now. Let's go and review some things we talked about. Obviously, you spent some time studying last night also. But more recently, we've been talking about lines that are everywhere the same distance apart and therefore never intersect. What do we call these lines, Noah? Parallel lines, good. We showed some things. If lines are parallel, certain angles are going to be equal, certain things are going to be true. But if I wanted to get lines parallel, there's certain ways to do it. In fact, in your class notes, you wrote down 6 different ways to prove that 2 lines are parallel to each other. Give me one of those ways, Brecken. What's one way to prove that 2 lines are parallel to each other? There's 6 options, 6 things to choose from. Lines will be parallel if you can get or show that.
2 angles are equal.
Okay, which kind of angles maybe, for instance?
Corresponding.
Okay, if corresponding angles are equal, then yes, lines are going to be parallel. Lana, another way to prove that lines are parallel.
Would it be something with sides? No.
I don't think that was on the list of things. Dylan?
Alternate interior.
Okay, if alternate interior angles are equal, then lines are going to be parallel. Lana, does that jog a thought maybe?
Maybe alternate exterior.
Okay, if alternate exterior angles are equal, then lines are going to be parallel. Josh? Michael?
Corresponding interior angles.
Well, corresponding angles, we've already said. There's no such thing as corresponding interior, but corresponding angles are equal. That would get lines parallel. Now, vertical angles are always equal, right? I mean, these 2 lines aren't parallel, yet these 2 vertical angles are still equal. That doesn't make anything parallel, though. Adam? Brandon's got something.
I think if the transversal was perpendicular.
Well, okay, it does actually kind of look perpendicular, but that doesn't make these 2 lines parallel. What? Oh, so if 2 lines are perpendicular to the same line, then they'll be parallel to each other. Okay, that is one of our ways. All right. Does that jog a thought? Show of hands, anybody? 2 more ways to go. We didn't study last night? Is that what you're telling me? Abby, she's like, moves her fingers.
Is it if 2 lines are parallel to the same line?
Okay, if the 2 lines are parallel to the same line, then they're the same line. Then they're lime. I had cursive, line. There we go. Then they're going to be parallel. And the last one was kind of a weird one, and it dealt with these 2 interior angles on the same side of the transversal. There's not a special name for them, but if something was true about these 2 angles, the lines would have to be parallel. Dylan? If the sum of the 2 interior on the same side of the transversal equals a straight angle, then there would be parallel. So 6 different ways we talked about to prove lines were parallel. A lot of other things we talked about recently, like converse statements. What's a converse statement? Back to Michael.
A statement that you can switch around.
Well, it's a statement that has been switched around, right? It's a statement that we already established as true, but then we switch the
If and when, then.
if and the then. There we go, the hypothesis and the conclusion. But the if and the then get switched. Are converses always true, class?
No.
What about if I take the converse of a theorem?
Yes.
Not always. What about the converse of an informal statement?
No.
No. What about the converse of a definition?
Yes.
That's the only time that you know for sure. If it's a complete definition, that converse will always be true. And then we talked about a type of proof where we assume the opposite of what we're trying to prove and then show, now that assumption's ridiculous, class.
Indirect.
Indirect or informal proof or proof by contradiction. Clear desk, except for a clean sheet of paper. And a pencil. Clean sheet of paper. And a pencil. Everything else away. Clean sheet of paper, pencil. Don't need a calculator. Everything else away. First last name at the top of your paper, along with today's date, which is 10/4/22. 10/4/22. If you lived in St. Louis, Missouri, you'd be celebrating Yadier Molina Day today. Any baseball fans out there?
Was there any that baseball? baseball?
Yeah, he played catcher for the St. Louis Cardinals for the past 19 seasons. We're number 4, so this is the 4th of October, so the mayor declared a holiday. Kids still have to go to school though, so it doesn't really matter much. But Yadier Molina Day. You can put that instead of the date if you want, or you can put 10/4/22. And this is quiz 10. Quiz 10. First and last name, 10/4/22, or Yadier Molina Day. And this is quiz 10. Let's take a look at the quiz together very quickly. Number 2 and number 3, you're going to pick one of those 3 words. Just write out the word. Number 4 and number 5, you will want to draw a picture to help you figure out what will be true. If this is true, then what else must be true? But you're going to want to draw a picture on 4. You're going to want to draw a picture on 5. Numbers 6 through 10 are straightforward. Number 10, there should be the word R right before the question mark, but it's okay. You can write that in if you want to. And then 11, 12, 13, look at that picture. 11, 12, 13, look at the picture that I already provided, and you're telling me what type of angles are these respective to each other. Okay, so referring to that. All right, use the quiz copy as a cover sheet. You may begin.